Next, we'll discuss our software design, including the vehicle detection, the speed calculation, size calculation, some of the communication issues that we encountered, and also time synchronization. First, I will show you an example of the magnetic sensor data plot. And this is as a car drives over one of our sensors. We actually have two different plots here overlaid on top of each other. The blue is a car going 3 miles per hour, and the red is a car going 30 miles per hour. Both of these readings are very similar. They have very similar features. However, when the faster car going 30 miles per hour passes over, it takes less time, so it's a narrow signal. And the car going 3 miles per hour takes more time to pass over the sensor, so the reading is wide. Next, I'd like to discuss our detection algorithm. It's actually a state machine which identifies key features of the vehicle's magnetic signature. In brief, when the DeLorean passes over the first sensor, we get a reading, and when it passes over the second sensor, we get a very similar reading, just slightly delayed in time. The first thing that we do is we take the absolute value of that signal, and we have a set threshold, and when the value passes over that threshold, we can actually calculate the speed of the vehicle in miles per hour between those 2 points. Then we're also able to estimate the size of the vehicle based on the time when it passes over the threshold and the time which it falls under that threshold, also taking into account the speed, because that also varies with the speed of the vehicle. Next, I'd like to discuss time synchronization. This is a very critical key component in our system. Without this, we would not be able to have successful speed or size calculation. The gateway and both of the sensors have to have very accurate time synchronization because they work based off of time stamping events in real time. So we spent a few months actually perfecting and testing this, and some of this information here is based off of some of the testing that we did back around Christmas. And this was a test over a 12-hour period. It consisted of about 83,000 messages, and out of that we had a average difference of about 0.28 clock cycles and a standard deviation of 0.5 clock cycles. This chart illustrates some of the communication issues that we encountered in our development. This is much like the game of golf. The higher the number, the worse. The lower the number, the better. So along the side here is actually the number of lost packets of information. And this is out of 6,000 total transmitted packets. And along the bottom we have the distance in meters between the sensor and the gateway. And we tested at various heights for the gateway placement. The sensors, of course, are on the surface of the Earth. And what we discovered was that having the gateway also located very close to the surface of the Earth, we encountered a lot of dropout. So by raising that gateway up, we can get a further distance, and this gives us a good idea of how far and how high we should place that gateway for optimal communication. The next plot here illustrates some of the communication issues that we encountered due to a passing car. Since these sensors are actually located, on the road surface and the cars pass over them, there is some interference due to that. And this top plot is the same plot that we looked at a little earlier. This is the magnetic field with the car passing over it. And as it passes over, down here at the bottom, we have a plot of how many lost data packets that we encounter. So you can see, as the car drives over the sensor, we incur a lot of dropout. So we had to develop our algorithm to wait until the car has passed over and then transmit the message. And now we would like to give you guys a demonstration of our project in action. We unfortunately weren't able to bring a vehicle in here, so we had to videotape this.
So we'll explain our setup here before we start our testing. We have two sensors on the roadway, and they are positioned 12 feet apart. We've measured this with a tape measure, so we know that it is exactly 12 feet apart. And then shortly over here off to the side of our road is our gateway, which is mounted up here on this tripod. The gateway receives the information from the sensors and calculates the speed and the size of the vehicle, then transmits that via Zigbee radio over to our computer, which is set up over here with a Zigbee receiver to receive that.
Here in a minute we'll show some comparisons with a radar gun, and you'll see the radar readout on the right-hand side of the screen and our readout on the left-hand side of the screen.
4 miles per hour?
Yeah, 4.
Right then.
Okay.
Sixteen. $34.
A little bit of time limit there.
60.
61.
I also quickly learned how long brake pads lasted after the 1,200 or so test runs that we did.